Welcome. We're now ready to turn our attention to quantitative data or numerical data. And we're going to start by organizing data into what's called an ungrouped frequency distribution. So let me show you the example. We've got the ages and years of a sample of 18 children in an art class. And what I'm going to do is find the range of that data set. So range is a measure of spread in the data. And in particular, it is the difference between the highest and lowest value in a data set. So we'll do some abbreviating here. We'll do R for range. So range is just the highest minus the lowest value in a data set. So if we scan that data, the highest age there is 13 years minus the youngest age is 9 years. So I have a difference of 4 years between the highest and lowest values. So because that range isn't very large, what I'll be able to do in my frequency distribution is list those ages going from 9 to 13 one by one. And that's why it's called ungrouped. So we can just look at 9-year-olds and then 10, 11, 12 up to 13-year-olds. And then we go through and we do some counting. So just trying to organize the data. So we're looking for the frequency, number of children that were 9, and it looks like 2. And then for my 10-year-olds, I have 3. And then if you want to count your 11-year-olds, that will be 4. There'll be 5 12-year-olds and 4 13-year-olds. All right, let's add that column. So the notation sigma, capital Greek sigma for add, or find the sum of the frequencies. So if we add those values, we will get 18. That was our sample size, so that's just a good check. I got all of the children into my table. So that's called an ungrouped frequency distribution. Just helps us get a little bit organized. And now we can answer this question rather easily. It says the age that occurs with the highest frequency is, so the highest frequency was 5. So there were 5 12-year-olds. So the age that occurred the most, it's called the mode. So the mode is the highest frequency data value, or the age here that occurred the most was 12 years. All right, so now we're going to move to grouped frequency distributions, because writing each value one by one is not always so helpful. So let's take a look at this example, and we'll start talking about the process here. So in this example, it's a survey. We have 13 people that reported the number of hours they spent on the internet last week. So I'm going to go ahead and start with the range here. So it looks like the highest value is 16 and the lowest value is 3. So the range, again, it's a measure of spread in a data set. So it's just the highest minus the lowest value. So 16 hours minus 3 hours is a spread of 13 hours between the high and the low. So we don't want to write 3 through 16 one by one. It doesn't really help us see trends in the data, and that's what we're after here. So I realize there are only 13 values, but essentially when we talk about organizing data, we're generally dealing with much larger data sets. It's just that we're doing these by hand, so we often do use small data sets. So if these values were in order, that would be very helpful in terms of starting to count values that are in particular age ranges, but we'll just leave the data as it is for now. All right, so let's start grouping some data. So we're going to have some instructions here. Construct the grouped relative frequency distribution. So we're going to start with frequency, and then we'll get to relative frequency. But first, we've got to set up what we call our classes. So classes are just groupings, ranges of values. And the instructions for starting, they say start with a lower class limit of 0. So we're going to create a group of numbers here, a class starting at 0. And it says use a class width of 4. So the class width is the distance from the start of one class to the start of the next. So if that's a 0, then we're going to add our class width. So that's our width, which is 4, and that will tell me where the next grouping, the next class begins. So 0 hours on the internet, that's 4 hours on the internet. So this first group then is going to go from 0 to, so before 4 hours, if we're doing, these are whole numbers in hours, before 4, the next previous whole number would have been 3. So we're going to look at people that spent 0 to 3 hours on the internet. And then for the next group, now, once you know the class width is 4, that also will be the distance between the upper class limits. So lower class limits and upper class limits. So now if I just add 4 to 3, that will bring me to 7. So people that spent 4 to 7 hours on the internet. And then we can just keep adding 4 here going down the page. So 8, 12, 16, and then 11, 15, and 19. All right, so those are our groupings. And then I'm going to come back to the boundaries in a moment. Let's just first do some counting. So frequency is the number of people in each of these groups. All right, so we're going to count everybody that said they spent 0 to 3 hours on the internet. So if we scan through that list from 0 to 3 hours, it looks like just one number there, 3. So one person responded somewhere between 0 and 3 hours. And then 4 to 7 hours, my next group. So numbers between 4 and 7. So there's a 7. 6 is between 4 and 7. Looks like just 2 people. So this is where I was saying if the numbers were in numeric order, it would sure be nice. It does make counting people in the groups a bit easier, but we'll continue here. So 8 to 11 hours on the internet. I think there's 4. Let's see, 8 to 11 would include 10, 8, 10, and 11. So 4 there. And then I'm just going to write the remaining 2. There'll be 5 people in that group. There'll be 1 person in that last group. I'm just going to add up those frequencies. So capital sigma F. That's supposed to be 13. They said 13 people. So yes, that's 13. So it's just a good check. And that would be called a frequency distribution. So those are our groups. So grouped frequency distribution. All right, I'll get to relative frequency in a moment, but let's go back to boundaries. So here's the deal with these boundaries. It says they close the gaps between the classes. So let me come down to this number line because in a bit we'll be doing some graphing. So let me write these limits. So the data were whole numbers. So the limits are always whole numbers. And 0 to 3 is my first group. I'm just going to bracket from 0 to 3. And then my next group were people between 4 and 7 hours, and then 8 to 11 hours, etc. So the groups here, the classes, there is a gap between them when we talk about the limits. So there's a space between the 3 and the 4 on the number line. Boundaries close that gap between the groups. So let me show it to you with this group. So what we do to create boundaries is we take the lower class limit of 4 and we go down halfway to 3. So I'm going to draw a parenthesis there. So from 4 halfway down to 3 would put me at 3.5. And then I take the upper limit 7 and I'm going to go halfway up to 8. And that would put me at 7.5. So those are the boundaries of that group. So you'll notice here the difference between those boundaries is the class width. 7.5 minus 3.5, that's distance is 4. And it also tells me then that there are 4 numbers in that group. So 1, 2, 3, 4. I'll draw dots on them. So 4, 5, 6, 7, 4 numbers in that group. All right, so let's talk about the next group then. So to create boundaries, we take the lower limit, 8, and we go halfway down to 7. So in that process, we actually end up right at the same 7.5 we had from that previous upper class boundary. So the boundaries always touch one another. And the upper boundary then of this group, 11, we'd go halfway up to 12. So that would be 11.5. All right, so that's that group. So the boundaries, these two values are always the same. So 7.5 to 11.5. All right, so with limits, there was a jump from 7 to 8 on the line, creating the gap, and the boundaries close that gap. And those boundaries is what we'll be using to graph later. All right, I'll draw one more here. So for 3, its boundary, we'd go up to 3.5. And for 0, that lower boundary, we would go down halfway to -1. So negative 0.5. All right, so the first grouping, the first class boundaries, negative 0.5 to 3.5. And then we can actually stop thinking so hard about this because we know the width is 4. So going down, you can always just add 4. So we would be at 11.5, 15.5, and adding 4 be 15.5 and 19.5. All right, one more thing then before we leave here. So we've got the data organized. We'll use boundaries later when we do some graphing. And now let's turn our attention to relative frequency. So it says to write your relative frequencies as a decimal rounded to the nearest hundredth, so 2 decimal places. So let's just first do a reminder here. Relative frequency, I'll write the formula here, RF, relative frequency. We take the frequency, but we divide it by our sample size. So there were 13 numbers when we added those frequencies. So that's our value of n, our sample size. So I know that one person spent from 0 to 3 hours on the internet last week. It was one person out of 13. So as a fraction, 1 over 13. The second group, 2 people out of 13. The third group, called a class again, the third class, there were 4 people out of 13, and then 5 out of 13, and 1 out of 13. And then we'll use our calculator here and write those as a decimal rounded to the nearest hundredth. So 1 divided by 13, hundredth would be 0.08. And then 2 over 13, 0.15. And 4 out of 13, 0.31. And 5 out of 13, 0.38. And then we're back to 1 out of 13. And I'm just going to point out that when we add the relative frequencies, if we're working in decimal, we're supposed to get 1, but we are rounding values here. So it's possible to be a little off from 1. But in this case, I'll go ahead and add these and see what we get. So 0.08 plus 0.15 plus 0.31 plus 0.38 plus 0.08 happens to be exactly 1. So if it was a little bit off, you're probably still okay, but just a good check here. So just be careful with your rounding. All right. So if we stopped at frequency, it's called a grouped frequency distribution. If we continue to relative frequency, it's called a grouped relative frequency distribution. And what we do next is move on and graph information, and we always have a choice of which of these we use.